Hey everyone, it's Rob Carrasco. I'd like to invite you inside the Pew Theater of the Dr. Phillips Center for the Arts for Siemens Spotlight on Innovation. But before we get started, I want to state this video is sponsored by Siemens and is shot in the VR 180 format, best viewed in a virtual reality headset. If you're watching this on a mobile device, you can pan and tilt to look around or drag the screen with your mouse if you're on a regular computer. Now, without further ado, I'd like to welcome you to Siemens Spotlight on Innovation.
To imagine what the future could be, to extend what's humanly possible. What happens when vision captures the imagination? Innovation is born. As a small startup in Berlin, Werner von Siemens and his brother turned their vision into pioneering technologies that have changed the world. Their artificial eye created the first one-pixel electronic camera, an innovation that led to modern-day television. From the artificial eye to artificial intelligence, from a startup to a top 10 global software company, Siemens digital technology is expanding what's humanly possible. Today, digital technology gives us tools to do things that innovators like Werner could have only dreamed of. Let's use technology to help industry and cities tackle today's challenges and those we haven't yet realized. Let's give the next generation of inventors the tools and the opportunity to change our world. Let's do it all while keeping purpose at the center of everything we do. Today, we turn the spotlight on you and ask,
how will your vision change the world?
Please welcome CEO, Siemens Corporation USA, Barbara Humpton.
Thank you. It is such an exciting afternoon to be here. We have such a fantastic program ahead of us. And I want to thank all of you for being here with us, and especially the folks who are tuning in online. In just a moment, you're going to hear from a stuntman turned CEO who's reimagining with video gaming, hot rodding for the 21st century. You're going to hear from a chief information officer from Newport News Shipbuilding who's going to show us how the Navy is building ships with our digital twin technology. And what about Chronicle, a Google moonshot company that's working with us to fight cyber attacks? And of course, from the city of Orlando, where our city performance tool is helping the community use data to understand how technology can set new pathways to meet their sustainability goals. And you know, Orlando is a perfect place for us to hold this event because it's our energy hub. It's where we have 4,000 employees. And it's a community where you can see the diversity of the kinds of projects we're involved in. From public attractions to the semiconductor industry, all the way to wind energy. In fact, this building that we're sitting in, the Dr. Phillips Center for the Performing Arts, is using our technology to keep the place secure and energy efficient. So thank you to the Dr. Phillips Center for hosting us today. Now, before we begin, I do want to take a couple of moments and talk a little bit about our broader purpose, the purpose of our technology. You know, from the time a human first picked up a rock and used it as a tool, tools have expanded what's humanly possible. Now, the rock didn't take over the job from the human, it just made things faster or better. And it's the same thing now with AI. Some people say that robots and AI are going to put humans on the sidelines. But that's not it at all. What we're capable of doing with augmented intelligence and robotics is like a new tool that is elevating the role of the human. This is the spirit that we bring as we work in technology at Siemens. And it's the same spirit that you saw from Werner von Siemens. The ideas he dreamt of in a garage in Berlin 170 years ago dealt with people. He was thinking about how people communicate, how people move from place to place, and how they live and work. We're bringing the same spirit and the same thinking to our work now as we deal with globalization, with urbanization, and with the increasing population growth that we have around the world. Take a look.
Roland, really appreciate you coming all the way out to California to hang out. I mean, it's super cool.
Yeah.
You spent much time in this part of the world?
On the West Coast, yes, because there's a lot of innovation happening, and innovation has always been the lifeblood of Siemens ever since it was founded, and you really have to stay tuned. You have to also try out something new, and you have to work a lot with partners. Our vision is that you are designing your product in a virtual space, then you build it.
I mean, these were things that just a few years ago, these applied technologies would have seemed as if they were in a futurist film, and we're actually applying them today.
I mean, you're pushing the envelope to the next level. You guys, you bring now the gaming industry, which the young guys, non-engineers are using, and they love it, and they make a lot of cool things. You bring that together and connect it to our tool chain. Everybody can be an engineer. And the autonomous, your product is really doing that. And that's really, I guess, the next level. You not only bring them individually into the game, but also collectively. Because obviously you can now have two guys sitting apart 5,000 miles, which we just had our first experience here, and make them work together on the very same model.
I'm already the other world.
Howdy, Livio.
Hey, I'm out.
Right on, can you see us?
I can.
Before, this was just fundamentally not humanly possible, that we were able to stand in the same room and have a full-scale 3D engineering design review across the country. It's just... It's fun doing engineering design review now. People would like to say, well, all this digital magic's great, but if you can't make it and you have to go back to tooling and the old model, it doesn't even matter really. But that was a big moment this year, that we could actually have additive manufacturing reach an industrial scale. But we saw the barriers of entry collapsing before our eyes to bring in an idea to life.
So the freedom of engineering is endless. I mean, you can bring almost everything. I mean, it's just about sending data and not molecules.
We're connected globally, manufactured locally. We're going to have a globally connected world on digital twins running around. And when we were running that thought of some kids in Munich that liked something that was designed in California, we're not going to manufacture it here and ship it across the planet. We're going to send the file, and it's going to be made locally in Germany.
Exactly. And then in Germany they might get it the Munich touch to it.
Yeah, okay. You know, people were talking a lot about kids in STEM education.
Yes.
But we're saying it's STEAM. We got to put the art and design in it, because
True.
we're going to have a lot of automation with AI So
I fully subscribe to this one, fully.
kids who previously didn't ever think they could create anything physical, artists, designers are really going to be set free.
You need a lot of very, very good arts engineers to design it such that you really can use it in a highly productive way. The more realistic it is, the more that people would interact with and really get a concrete feedback on the product. Sometimes if you have just a drawing, then they say, oh, I like it. And if they see it in real, then, oh, well, it's so big, or it does this and that. If you're really in the virtual world and you can walk around it, dive into it, then you have really good feeling on, this is what I get. This is a product I like.
What we were doing was fairly significant. We were communicating with your team in Princeton, New Jersey from Ventura, California in real time.
Yeah, absolutely. I mean, it was a great experience. After only 30 seconds, I was in a virtual world together with you and other people from Princeton. And it was really, we were walking around a car, looking at it, how is it designed, where are some design flaws maybe, which we might want to change.
And here, if you look here at the wheel, the clearance here is probably not sufficient.
No way. If you hit a pothole there, you're going to rip the fender off.
For me, really, as if it would be almost in the real world. You know? After a while, you are there. You are in this virtual world. Our people and I am really excited. It's somehow a new world which you are opening up. We are happy to be part of it. We see how we can together shape this journey.
Cut.
Good.
Ladies and gentlemen, welcome Ross McGraw. This is so cool. What are we looking at?
We're looking at the world's first motorcycle that was designed, engineered, and printed straight out of a video game.
How long ago did you start working on this baby?
We actually were greenlit by our partners at Oak Ridge National Lab that said they had capacity to print the tank in aluminum 2 weeks ago. So we went from concept to 3D model, connected globally to our design team, and then threaded out to manufacturing and delivered here in 2 weeks. From clean sheet to product. And if they would have let me put gas in, I could have rode a wheelie on here to show you.
I love it. So, hey, so you designed this virtually. When it arrived, how much work did it take to actually get this integrated in?
It actually stitched together perfectly, and that's a super important point. I've never seen this motorcycle physically until yesterday. I've been looking at it, working on it virtually, and the files went out to manufacturing, but I had never seen it, and nor had we ever done any lineup physically of any pre-prototype parts. The parts then were manufactured, like this tank was built by Oak Ridge National Laboratory, and it's aluminum cerium, so it's a real high-speed aerospace grade material. So think about this, an aerospace grade part came out of a video game on demand.
That's awesome. Yeah, I hear wow from the audience. That's so cool. Hey, talk to us a little bit about the partnership that we've got and the relationship between all the parties you're bringing together.
Well, we couldn't be more happy with this partnership overall. I've had a saying for a while, it says, watch what happens when you put a game engine on top of the world's most powerful digital industrial portfolio and set the kids loose. It's an exciting moment, and you guys are fulfilling so much of the technological capability to go from the digital, from the game file, all the way to the physical file, through factory automation and into production.
That's fantastic. You know, I've been sharing with a lot of people that I've got a real interest in this because we're trying to build the workforce of the future. So this concept that folks who know how to play video games could be great candidates for engineering. How do you see all that working?
Well, I think it's going to be an eruption of possibilities and opportunity for the next generation. This is not about disruption overall. It's going to be bringing the barriers of entry down, collapsing them, so any kid with an inspiration or a dream is going to be able to get in their comfortable working environment in gaming. We're all digital natives here, and they're going to be able to bring their idea to life, but it's just not in a fictitious way. That is not ready to go to be product. So you could think kids could start the next Hot Wheels in their bedroom, start koi companies, they could start motorcycle companies, anything in the industrial space can become realized.
Yeah, so I mean, one of the things we saw obviously was you and Roland working with Livio.
Yeah.
Livio's in Princeton, you're in Ventura, you're obviously crossing boundaries here. I loved Roland's comment about, yeah, maybe Munich will put a little Munich touch on it.
Yeah.
Talk to us about kind of how you're envisioning this kind of collaborative space, and how important is it that we have the virtual reality aspect of it?
So, as you saw, we actually did a multi-person, multi-location photoreal engineering design review. And the virtual reality, as Roland was saying, being totally photoreal, and you're able to make decisions so fast. So, for instance, I never saw this bike, and I looked at it in VR, I said, yeah, make the fender that long, make it this wide, boom, was done. I came back in 5 minutes, I approved the design that went straight to print. And collaborating across the world that way is going to just completely open up the potential of how you create new businesses.
Yeah, you know, it's funny. You're talking about this, and it almost makes you think that, hey, maybe I can plug and play parts, you know, put things together. People can invent components that are then reusable. I mean, how do you see this building out?
Well, you're going to see a multi-dimensional new environment come. We'll be hearing more about Web 3.0 and the spatial web. So you're going to have an entirely new collaborative ecosystem for business to take place in a three-dimensional world. So we're going to see the emergence of the spatial web. And this is going to be sort of the foundation for how businesses will be born overall.
Yeah, now I'm looking at a couple of things. What's this on the front, Mouse?
Well, there's a little personalization there. My racing number was 52, so I sprayed motorcycles. This is really cool. So our partners, HP, and your partners as well, they printed this overall. And so this is a number plate and a headlight overall. So that's side plates. Oak Ridge printed the rear fenders in carbon composite. Obviously that's aluminum, and that's another composite material overall. But check this out. We exploded that file in the game. HP took a few files. They then threaded them out to their manufacturing partners.
Yeah.
So 3 different vendors from HP actually built individual parts. Oak Ridge did these, and then they were all delivered, and we actually assembled the bike here yesterday. So that was like, so if you think about it, fully connected, but distributed manufacturing. We're looking at a future where we won't have to have monolithic factories. We'll have manufacturing be distributed, and then you'll end up with local assembly, and this is going to create so much opportunity.
Great.
I was shot in Afghanistan in 2012. I've always been an active person. I'm not gonna let it hold me back. I have a prosthetic foot. It allows me to be very active, but it's a bit heavy. There was a student interested in doing some kind of biomedical engineering project. Well, maybe she could redesign a lighter, more versatile foot.
We took the whole foot apart and we had crazy ideas. The goal would be to knock off 40% of the original weight. Siemens software lets me design and test the foot before we ever actually build it. This has taken almost a year to the day.
It does feel a lot lighter. Having a lighter foot is going to open up possibilities that would not have been there before. You know, the more kids that learn this stuff at earlier ages, they can go on to create new and better things that we're not even dreaming of right now. It's amazing.
Fantastic. This whole experience started with you getting interested in a real problem, and you were using the tools available to you in school. Tell us about it.
Yeah, so I started in the Green Power program, which is a program for middle school to high schoolers where we design little electric race cars. I mean, that's how I started learning these engineering, skills that I would need to work in this project. And I got this mentor who said, hey, my brother lost his foot in Afghanistan, and I know you're interested in biomedical engineering. Would you be willing to take on this project? And of course I was like, yes, of course. Like a new project that I can use what I've been learning over the past 3-4 years to actually help somebody.
A single block in Brooklyn is pretty self-sustaining. We rely on each other. I don't have to go far to get what I need.
It's a place where I raise my family, where my kids go to school. Our community really provides the foundation of our lives.
There is a constant interaction and exchange with those around me. Even though we share all of these products and needs with our neighbors, the one thing we haven't been able to share is the one needed to make any of it happen: energy.
The microgrid, a power system in miniature, is changing the way we think about community and how we can interact with our neighbors. Using a network of community solar panels, it strengthens the infrastructure, providing additional power generation, storage, and transactions between households.
Neighbors can harness excess energy and sell it to other tenants in their building, or neighbors across the street utilizing LO3's blockchain ledger technology.
This exchange of energy is made possible by Siemens microgrid software, which couples the LO3 blockchain program, serving as the virtual backbone of the entire system. It enables the transfer of energy between prosumers and consumers, and also provides real-time analysis of supply and demand across the system.
It actually allows you to put a face to your energy provider, and not just any face, your neighbors.
The microgrid aims to strengthen your local grid and reduce disruptions that are caused by incidents tens or even hundreds of miles away, leaving you unaffected. In dangerous situations like Hurricane Sandy, while the rest of the city may lose power, you and your family can remain okay. Literally powered by your community's microgrid. Every generation.
How we interact with one another is constantly evolving.
This technology is bringing something fundamental to the neighborhood.
And with software that makes the whole microgrid smarter, Siemens is working with LO3 to help neighbors across America control their own energy and their future.
Please welcome City of Orlando Mayor Buddy Dyer and Global Head of Urban Development Siemens, Martin Powell.
Thank you, Mark. It's a pleasure to be here.
This is an amazing venue, the Centre for Performing Arts, which ironically we've managed to fill with engineers. The Mayor and I included, by the way. Before we get into the conversation, I'd like to just frame the conversation a little bit. Cities are powerhouses of innovation. They're complex, emotional, cultural hubs that is very easy to throw off balance. And the reason we at Siemens have been so focused on cities are the unprecedented challenges that they now face. And these pressures and stresses can really disturb that balance. For 16 years, Mayor Dyer has brought partners to the table to leverage technology to transform the city, to ensure the city can be competitive and attract the very best talent, and keep the very best talent. And the Mayor's also leveraged technology to diversify the workforce and build, I must say, one of the country's premier sustainability programs. For that, you should be absolutely commended. And including this incredible building, which is brimming with Siemens technology, I may add. Michael's president of 100 Resilient Cities. This is an organization founded 6 years ago by the Rockefeller Foundation. Michael, over these 6 years, has very successfully put 83 chief resilience officers embedded in cities across the world, which is a very, very impressive feat in such a short period of time. And these people are now working to think about this future-ready city concept. On top of that, Michael's a great colleague. We've been working with 100 RC for that whole period. He's also a good friend, so please welcome Michael Berkowitz. Thank you very
Thank you very much, and welcome to the second part of the panel. As Martin mentioned, I'm Michael Berkowitz. I'm the president of 100 Resilient Cities. And when we talk about resilience, really we are talking about future readiness. It's about the ability of a city to survive and thrive in the face of whatever the next disaster is. And so that's why I'm so excited, so thrilled to be here. Of course, we're joined by the mayor, who you've just heard from, and we're going to come back and talk a little bit more and try to get into a little more depth with the mayor on some of those issues. To my left, there's Catherine Stympian. She's the state president for Duke Energy, which has roughly 2 million customers here in Central Florida, as well as Tim Vanderhoof. He's the senior vice president for business development for Enterprise Florida. And I think it's really interesting that the two folks on my left really thrive in a sort of more forward-thinking, longer-term planning environment, because that's the business that they're in. They need to anticipate the future. And me and the mayor were talking a little bit backstage. Being the chief executive of a city, you've kind of got two hats. In some ways, you're fighting the most recent crisis, and so you've got to get through the news cycle, through the week, through the month, through the hurricane season, whatever that thing is. And at the same time, you need to be more strategic and think more long-term. Talk a little bit more. We heard you talk about adaptive and flexible in the previous panel, but talk a little bit more about how you do that practically.
You use the term resilient, and there's two ways, I think, to look at that. One, we've had the ultimate opportunity for resilience, which was after the Pulse tragedy and how we rallied together as a community and came back from that. But also, I think being resilient and future-oriented means being ready to take advantage of opportunities and being strategic and intentional about being prepared to take advantage of some of those opportunities. So I was out with the wireless folks yesterday and talking about how to deploy 5G. And that's I could put that in that same aspect that I'm talking about, being resilient and figuring out how to deploy it, because a lot of cities are fighting against it because of the aesthetics of what the nodes are going to look like hanging on poles. But we did a code amendment 3 years ago to allow for that technology to come into the city. And yesterday I announced that not only are we doing that, but we're doing a master plan where the companies can come in and have all of their possible configurations approved from the outset. And then when they come into permitting, they can simply say, we're going to use configuration A, B, or C at this particular location. And that eases the permitting process for both sides, for both them and for us. So that's, I think, forward thinking or future thinking on how are you going to get 5G technology here.
Right.
Artificial intelligence is changing our world, giving technologies new purpose. In energy, Siemens is using AI to make its world record-breaking gas turbines cleaner. 2 Siemens researchers are using AI to better control gas turbines in the US and South Korea. Artificial intelligence knew how to find the gas turbine's sweet spot, so they can operate as efficiently as possible and even reduce emissions. And at Siemens Energy Hub in Charlotte, North Carolina, teams are using digital twins to streamline the gas turbine component design and manufacturing process. The software allows engineers to surpass 2D models and instead create a data-rich 3D model for integrated additive manufacturing. The tools can reduce production lead times by as much as 20%, simplifying and accelerating production processes. Across the U.S., industries are unlocking the potential of digital twin technology to drive innovation and to do things that have never been done before.
Please welcome Siemens Head of R&D in Automation and Digitalization, Dr. Norbert Gauss.
It's a great pleasure to be here and to kick off a session now on artificial intelligence and the digital twin. before we then have two customers who actually did it, used it, and we can hear what they did and how they did it, and what the impact to their company was, how it benefited them. Now, let me start with this slide. That basically shows our vision of Siemens when it comes to digitalization from a holistic point of view. You see a broad range of products we have. All those products are or becoming intelligent and connected. They generate data, they process data, they communicate with one another, and they're connected to a backend. Then we also have a very broad range of software tools that support the whole life cycle of products and plants, from designing to manufacturing, installing, implementing them, operating them, and servicing them. In between, we have a platform that drives the connectivity into the field, that hosts the data coming from both the applications and the models from those applications. And it also provides an ecosystem to implement new software applications for both us, for our partners, for our customers. So it's a whole range of very broad range of many technology areas that really contribute to this vision. Now, why artificial intelligence and the digital twin, or the power of these two? I believe these are the two technology areas out of many of them that contribute to this vision that really stand out. Let me explain this. If we talk about digitalization, digitalization means we have to do things, many things we used to do in the analog world, in the digital world. That can only be done if products and plants have, from all different aspects, a digital counterpart that links the digital world with the analog world, with the physical world of our products and plants. That's why the digital twin stands out. Now, if we wouldn't have a digital twin, we couldn't really do digitalization at all. Now, the second technology I think that stands out is artificial intelligence, because the value of digitalization lies in generating value from data, data from products, data from applications. So that's why these two technologies are standing out, and interestingly enough, they start to really now come together and jointly drive us into many new areas and avenues. And now let's look at a few of them. What is happening already before we see from some of our customers. On the slide you see 4 examples. On the top left, it's called generative design. So what we do in designing products, mechanical products, or even electronic circuits, we usually explore a design space, and then we simulate design alternatives and decide on the best alternative or option that comes out of this design space. Now with the help of artificial intelligence, we broaden the design space and automatically generate many, many more alternatives. Now, with many, many more alternatives, we cannot go through timely and costly simulation cycles. Every one of them is many CPU hours. So we use artificial intelligence to pre-select design alternatives before we go into simulations. We pre-select or deselect, so that we then, after broadening the design scope, we reduce the alternatives that need to be evaluated, and we can choose from a much, much broader set to come up with more innovative products. And this is happening really across all industry sectors. Where it's starting is a little bit different from company to company and from market to market. But it's not that any market does not see the potential of this. And if there's anybody here who doesn't see it yet, chances are one of your competitors is doing it already, and you're falling behind. So this is a potential, I think, for everybody. And now you will hear from 2 customers what they do and how they do this. Now, unfortunately, there is no picture of a ship on this. But now you will hear from Bharat Amin, who is the CIO from Newport News Shipbuilding, how they are using this technology and what the impact is on his business and his company. Bharat, the floor is yours.
Good afternoon. So, just like to do a test here. How many of you know about the products? I know we build ships. How many of you know what products do they build? Just raise your hands. Just a couple of, okay. So, let me start off with the introduction of our company. So, let's see.
Shipbuilding is the sole designer, builder, and refueler of U.S. Navy aircraft carriers and one of 2 providers of U.S. Navy submarines. For more than 130 years, Newport News Shipbuilding has built the most advanced ships in the world, using our expertise, engineering and design, and manufacturing. We are the largest industrial employer in Virginia and the largest shipbuilding company in the United States.
So that's what we build. 2 products, maybe 3 products for only one customer, Navy. So let me talk about new age in digital disruption. I want to start off. We are a 133-year-old company. And how do you get to digital twin? How do you get to artificial intelligence? You have to work hard and you have to plan it out. So I know that people predicting things, and you can see on the screen, 1.9 billion mobile workers are expected by year 2023. It also says 94% of the data that will be processed in the cloud by 2021. And did you know that 90% of the data that exists on this planet was only created in the last 2 years? And I've been checking that it's every year it's same. So that means it's happening at faster pace. And 25 billion connected things by 2021. When you have that kind of disruption happening, you can see the companies, how they're taking advantage of it. And there's a quote from Pierre Nanterme, he was the previous CEO of Accenture. He said since 2000, 50% of the companies disappear and they have something to do with digital. And then I have another quote from InnoSight, and that says at current rate of change that's happening, 50% of S&P will disappear in the next 10 years. This is all because of digital. And my view is that the change that's going to come in the next 5 years, it's going to outpace change that has taken place in the last 50 years. So that's the kind of environment we are in. I want to make sure Newport News is not going to be in that statistics. If you think about shipyard, there is 550 acres of land. It's like a city. And we build floating cities. The nuclear aircraft carrier life is 50 years. So if I take the first aircraft carrier of any class and the last carrier of that class, the whole digital thread is about 100 years.
You know, my great-great-grandchildren could potentially be sailing on Ford-class aircraft carriers. The Ford class is replacing the Nimitz class. The ship produces a lot more electric power. It produces a lot more fresh water. It produces a lot more cooling capacity than the Nimitz class. We've been able to remove a lot of ship's force people off of the 50-year life cycle cost. So the Ford class total ownership cost is about $4 billion less than the equivalent total ownership cost of a Nimitz class carrier.
We are preparing ourselves to accommodate the future workforce needs, and we believe that technology is going to play a big role in it. So we constantly show a picture of one of our employees' daughter. She's 5 years old and she's using iPad. Now think about that person coming in 2028 to come work for us. That's all they're going to know.
The next evolution revolves around a digital ship, which really means, for us, a drawingless ship. Since the dawn of shipbuilding, we've always used drawings. Think of it in these terms, you know, you have to carry around an entire stack of paper in order to go do your job. The fact that you can have a very pointed piece of data, you know, video, a digital image, changes the dynamics of how they build.
So drawingless to us meaning we take the models that we have in digital form, use those models in a smart way on a mobile devices so people can use those devices to produce, cut steel, or do whatever they need to do. We will have digital twins where we can actually fully have a digital ship, operational ship, where we can simulate things and try out things before we physically find the problems.
An integrated smart shipyard is the foundation for us building our products more efficiently.
We're essentially taking that digital model, breaking it up into large Lego chunks, and then bringing those Lego pieces together from the keel up to the upper yardarm.
We use NX as our design tool and Team Center as our information control system for product breakdown, work breakdown, bills of material. So configuration managing this massive data set is a huge part of what our workforce does every day.
And the power of the digital thread, basically, you could see it firsthand from the workers. And then the ideas just start springing alive from them. They come up with their own uses or innovations. They make their own work instructions. That's when you knew that there's a big change coming about for how we do business.
And we call this 100,000 ton of diplomacy. So wherever it travels, it brings diplomacy in the different parts of the world. Thank you.
Thank you very much. I mean, that was very impressive, and I think it's a very bold change to a company that needs to manage a 50-year life cycle. Now, if NX can do that, it can probably do anything, and if you can do that, you probably also can do anything. You know, I've been visiting and seen many factories, but being able to visit one of your factories, that would be thrilling.
Absolutely.
So,
awesome.
thank you. And now from shipbuilding to a very different industry, and that is electronics. Let's welcome Chester Kennedy. He's the CEO of Bridge.
Thank you, Robert. Thank you, Siemens, for allowing us to be part of this show today and just seeing the innovation that's here and for the partnership that we have with you. How many of you are really confused now? We talked about digital length, we talked about digital thread, we talked about digital twins. Everybody really confused about what all that is. Well, you're probably not nearly as confused as I was the first time that I heard the term digital twin, which was probably a little more than a decade ago. And we were competing on this little airplane project when I was with one of the aerospace companies. Some of you know who that is and can figure out what program that was. And the folks came forward and said, well, we've got to create a digital twin. And I said, well, what in the world is a digital twin of something as complex as a state-of-the-art fighter aircraft? And they said, well, you know, we've got to have this really accurate digital model that will allow us to do prognostics. And I said, well, what do you mean by all that? And I said, well, if the airplane's deployed in this environment, you know, what's going to break? If it's an assault environment versus a sand environment, and one sand environment's different than another sand environment, and we've got to be able to put all that environmental stuff, but we also got to be able to play that with models of how all these mechanical systems and all the electrical systems are going to operate together, and we've got to be able to predict what's going to fail because we can't rely on the maintainers to have to order parts. We've got to ship them in advance of when they're going to need them based on a forecast of what's likely to be breaking. And I'm thinking, oh my gosh, this is a complicated model. And then they said, and each one's got to be different. And I said, what do you mean each one's got to be different? And they said, well, each serial number on the airplane, you know, we have tolerances in the manufacturing process, and we don't want to create a generic model. We want to create a specific model, and if this particular part was supposed to be machined at 1 inch plus or minus 2/10 of 1/1000th of an inch, then and it was on the low side of that, we want to create one that is really running that kind of realistic. And when we have 3,000 aircraft in the fleet, we'll have 3,000 of these models running simultaneously, and every time there's a maintenance action, we'll keep it up to date. So anyway, that was my first overwhelming exposure to the concept of a digital twin. Well, fast forward that a little more than a decade, and I find myself trying to stand up a microelectronics fabrication facility here in Central Florida in a very unique public-private partnership, and something that we're real proud of, the region really coming together and pooling its resources from the University of Central Florida, the Orlando Economic Partnership, and Osceola County, one of the governments here in the Central Florida region, saying that we're going to build some infrastructure to help fuel the innovation economy that hopefully you all are feeling as part of your visit here in Central Florida. and create a venue where anyone that needs access to the infrastructure to make the next generation microelectronic components can come and take advantage of that. So it's a really exciting project, and we're in the process of standing that up, and my team says, well, you know, one of the things that we're going to need is a manufacturing execution system. We're going to need some really powerful software to keep track of all the, what we call recipes, that go into manufacturing the microelectronic devices. And if you're not familiar with that world, we'd love to have you come out and have a chance for us to give you a little tour and show you what it takes to really create microelectronic devices where we're trying to control the accumulation of materials down to 1/1000th of the diameter of a human hair and stacking those atoms in a very specific order for very specific purposes. And so there's a lot of things to keep track of. You know, there's gas flows, there's temperature variations, there's time durations in the chambers, there's just lots and lots and lots of things that you have to keep track of. And so we're having this discussion about the manufacturing execution system, and Siemens comes into the conversation. They were one of the folks that had responded to our RFP for a manufacturing execution system. And they said, you know, what if we turn this into some kind of a joint project? Yes, you need a manufacturing execution system. Yes, we've got a product called CAMSTAR that's in our portfolio that can meet your needs. But what if we partnered together to really take the power of the Siemens industrial base, all the things that you've learned in so many other domains of implementing this concept of digital twin, so you can start to see the nightmares start playing back in my mind about that conversation from a decade ago.
Siemens, ingenuity for life.
Please welcome Vice President and Global Head, Industrial Cyber and Digital Security, Siemens, Leo Simonovich.
Digitalization offers enormous promise to uncover insights, optimize operations, and generate new revenue streams. This is especially true for industrial IoT, which has been slow to undertake the journey, but where arguably opportunity is the greatest. Unmanned power plants and offshore platforms are not the dreams of tomorrow. Siemens is working with customers to make them a reality today. Yet, a recent wave of mega attacks with ominous sounding names, WannaCry, NotPetya, Triton, and most recently Norsk Hydro, have led to millions of losses and near-miss safety events. The knee-jerk reaction is to go to the extreme. No connectivity, even to provide insights. No third-party components or suppliers as they introduce vulnerabilities. No patches as they can trip a plant. And ultimately, no analytics, cloud, and high-performance computing leading to missed digital opportunities. The net result? A breakdown of trust in both physical and digital worlds. The reality is that industrial assets were never designed with security in mind. Digital was simply bolted on top. The primary purpose was to withstand decades of around-the-clock production, weather, and safety, but not connectivity, and definitely not AI. With convergence of physical and digital worlds, operators are faced with a perfect storm, having to address the basics while dealing with machine speed attacks. Today, the core challenge of protecting connected infrastructure is visibility. You cannot protect what you cannot see. Most don't know what threats lie within their fleet, how vulnerable they are, and what to do about it. This is especially true for small and medium-sized enterprises. The salient example that comes to mind is a December 2015 cyber attack in Ukraine, where 225,000 homes lost their power in the dead of winter. For the first few hours, the operator didn't know he was experiencing a cyber attack. He thought his control system was malfunctioning. Customers require transparency, context, and a dedicated OT approach that will not only safely monitor the environment, but also allow them to confidently take action. An illuminating lesson from the US Army teaches the importance of visibility. It was more than a half century ago that Army researchers started working on night vision technology. They wanted to empower soldiers to see as clearly in darkness as they could in light. It all started with the principle that you simply can't defeat an enemy you cannot see. Fast forward to last summer, the Army issued this new technology that gives soldiers night vision capabilities once thought to be impossible. One general said that it will enable soldiers to, quote, own their environment. This is exactly why we're partnering with Chronicle, to take a different approach to security for the industrial space, to help our customers own their environment. We call it process security analytics. We need to apply a different kind of analytics to gain visibility into anomalies, get context around an incident, and act to neutralize the threat. And by instilling transparency and confidence, we can restore trust to fully take advantage of the digitalization. Now, I would like to introduce my colleague from Chronicle, Mike Wychek, who will provide more detail around the partnership and what it means for our customers.
Please welcome Siemens Head of ARC,
Thanks, Leo, and thank you for having me at this event. I'm a co-founder of Chronicle, and for more than a decade, I've been building the systems and techniques that Google and now Chronicle uses to protect themselves from advanced persistent threats, the nation-state attacks that can cause such enormous harm. To start, we need to acknowledge the new reality of our world today. As billions of devices are brought online, and as the physical and digital worlds converge, we are increasingly living in a world where threats are omnipresent and targeting the very technologies that are designed to improve our lives. Our ability to analyze information in the face of these threats is a necessity. At Chronicle, analytics are in our DNA. The company was born out of Google, where we were constantly developing new techniques to stay ahead of attackers. We studied how these actors evolved their tactics, techniques, and procedures, and we did the same. Now, to bring the same level of capability to other organizations, we developed Backstory, a global security analytics platform designed to collect, integrate, and store petabytes of data. And with our Siemens partnership, we can use Backstory to tackle the interconnected world between IT and OT. At its core, Backstory provides us with both visibility and context. It can conduct forensic analysis and investigations of behavior so that security analysts can look back across time to identify and understand unusual activity that could indicate that an attack is or was underway. This is why our partnership with Siemens is finally providing a solution that bridges the IT and the OT worlds to create a new approach to industrial security. With visibility and context, an analyst can trace activity from the OT network back to the IT network, identifying gaps and unpacked systems that enable an adversary to enter a network, establish control, lay dormant, all waiting to take over and force a shutdown. Let's talk a bit more about visibility and context. Visibility is grounded in developing a continuous situational awareness of what's happening in both the digital and physical worlds. Now, to do this, we need to consume so many types of data, and in volumes that are almost incomprehensible. Being able to store this amount of information, let alone study it for those key links that may identify a cyber attack, is near impossible. But with Backstory, what was once impossible is now a reality. For instance, in the Ukraine example that Leo referred to, the way to determine if there is a real attack or a system malfunction would be to analyze control system data and correlate it with network data. Something impossible before, because operators lacked visibility into all systems at once. But now, looking at two systems never designed to work together, we can understand that the errors are the result of intentional malicious activity. The next key to our approach is context. Even after diagnosing an attack, the operator is still powerless to act because operators cannot understand how the attack is impacting the systems, its reach, or its intent. Now, this is where context matters. A better way to think of this is pattern identification. How quickly and how accurately can you examine normal asset behavior versus abnormal behavior? By identifying patterns in backstory, Siemens security analysts can build a picture of what's happening, its potential impacts, with enough time to do something about it. Now, equipped with insights, Siemens OT specialists can work with customers to build systems tailored for critical infrastructure and industrial technology, and when necessary, take action. In most cases, unlike what you've seen in James Bond movies, it does not mean a system shutdown. Rather, it's about working with customers to develop options that balance operational, safety, and security constraints. It's about building the confidence to take a proportional and appropriate response quickly and decisively. I'm joined by my co-founder, Shapur Negibzadeh, who will give a short demo of the system I've described. Here we have a demo of the Havex malware that targeted power plants in the past. Shapur, please walk us through the process.
Thanks, Mike. So I'm going to walk you through a demo of what a real-world attack against the electricity grid looks like in backstory. This advanced persistent threat that we'll look at, or APT as we refer to them, is a state-sponsored actor that has been using a malware known as Havex since at least 2013. Within the energy sector, Havex specifically targeted energy grid operators, major electricity generation firms, petroleum pipeline operators, industrial equipment providers, compromising thousands of devices in the process. Their goal was simple: to map out the environment, gain persistent remote access, and then lay dormant, waiting for a central command. Now, today we know a lot about how the attacks are carried out from our own research at Chronicle, as well as data from our Malware Intelligence Service, VirusTotal, and forensic analysis that was painstakingly pieced together by the security industry over the years. The reason why these attacks have been successful is that we lack visibility into these environments where the attacks were carried out. As Mike mentioned, we're enabling Siemens to bridge the gap between IT and OT by ingesting low-level telemetry at planet scale. You can see this in the sheer volume of data we're ingesting into the platform. Just in this demo environment, we have hundreds of terabytes of data from several disparate data sources.
Everyone, thank you so much for joining us this afternoon. I hope what you've been able to see is that people using technology to bring value to society, this is elevating the role of the human. This is extending what's humanly possible. And I hope that you're inspired and energized yourselves. Let's keep the conversation going on social media. Join us on Twitter, on Facebook, and on LinkedIn. Use the hashtag Siemens Innovates, and we'll keep this conversation going. But I have one more question for you. How will your vision change the world?